All right, so we're going to look at another example of how to use work, especially when there's a variable force. And so here's the example that I have. We're pushing a block once again, and pushing that block with a variable force. So what I've decided is I created a force versus distance graph, and the variable force is from 2 newtons to 4 newtons linear over 10 meters. All right, so this is similar to the other example that we did, but now I have a variable force. I can still predict the speed of this block, but now I don't have simply force times distance, right? So just like before, work equals the kinetic energy in this case. And work is still force times the distance. That doesn't change, but the way I've written it here really means average force. But there's another way to look at that. Look at this graph over here. We have a force versus distance graph. This is the area of a force versus distance graph, something similar to what we've seen before. So if I calculate this area, then I can actually calculate what the velocity is. All right, so well, what's the area? So one way to do this is I could use the trapezoid formula. So I've got 1/2, the base is 10 meters, and it's 1/2 because I'm going to basically average these, right? 2 newtons plus 4 newtons divided by 2 ends up being the average force. And so that ends up being 3. So this is the amount of work. So that 6 divided by 2 is 3. Times 10 is 30 joules. So I'm doing 30 joules of work here. So I can use that instead. So I'm going to then solve for V just like I did before, but I'm going to leave force versus distance. I'm going to leave it as work because I just figured out how much work I did, how much energy I transferred into the system. And so then I'm going to have V squared equals 2 times the work divided by the mass, and I'll have to take the square root of those, right? So the velocity is going to equal 2 times 30 joules divided by 5 kilograms, and then I need to take the square root of all that. And so that's 60 on top, that be divided by 5, that's 12, right? So the velocity, and I won't get the decimal form, but the velocity will end up being the square root of 12 in this particular case. And so being able to use a force versus distance graph and using that area under the curve will actually tell you how much work is being done on a system. So hopefully that helps, and I will see you next time. All right, the only way to learn physics is by doing physics. And so let's look at this diagram that we have here. So we have a graph that shows a force over a distance. And so we're going to take a 2 kilogram block and we're going to push it with this variable force on a frictionless surface. And we're going to assume that it starts at rest. So you have a 4 Newton force applied for the first 3 seconds, and then it drops off to 0 over the next 2 seconds. So first thing that I want you to do is I want you to think about an LOL diagram, but I want you to calculate the amount of work that is being shown by this graph. Hit pause now, do the calculation, and unpause when you're ready to see the solution. All right, so here is the solution. The area of a force versus distance graph gives us the amount of work. And so what I put together was a rectangle and a triangle. The math is shown there, and you ultimately end up with 16 joules of work that are being done onto the system. So now the next step is to come up with an LOL diagram and use that LOL diagram to solve for the velocity at the end. So hit pause now and unpause when you're ready to see the solution. So here is the solution. I didn't have space to do the LOL diagram, but we can always think about the initial energy plus work equals the final energy. So in this particular case, it said that we were starting with no speed. And there's nothing about change in height here. So my initial energy is 0. and then I have work done on the system that we calculated before. It was 16 joules, and that's going to equal whatever the kinetic energy is at the end. And so kinetic energy is 1/2 mass times velocity squared. So I substitute that into the equation, and ultimately I can solve for the velocity as shown here. When I solve for the velocity, I end up figuring out that the final velocity is 4 meters per second. So keep practicing these type of questions so that you can get better.